Hello CNC students, Mr. Cowley back again, talking about another, this is somewhere between the basic math class and also beginning of a programming class. And what we want to talk about today is our CNC milling speeds and feeds. Now normally, I really believe in having our formulas written down, having them in a book, having them at your fingertips, and not doing a lot of memorization. But this is really a case where I want you guys to learn and memorize these two simple formulas. And these are going to help you every day when you're programming your CNC mill. First one we're going to talk about is the speed. When we talk about speed in CNC milling, we're talking about the RPMs that your spindle is going to turn. And as you know, in your milling programs, that's going to be designated with normally an M3 for spindle clockwise, sometimes an M4 if you have a left-hand tool. But we're going to talk about the turning speeds, the RPMs that are normally our mills, our end mills are going to turn at. So that formula is pretty simple. It goes like this. 3.82 times surface foot per minute divided by the diameter. That is going to equal our RPMs. So let's take a look at this for a minute. 3.82 has to do with the change from inches to feet, so it's a 12 divided by pi. Don't worry about that. That's a constant. And that constant, we're always going to use 3.82. The second one is surface foot per minute. So that one gets a little more technical. So what is our surface footage? Well, it has two factors that determines that. One is going to be the type of tool we're using. So some end mills, depending on the coating, depending if they're high-speed steel, or depending on if they're solid carbide, will determine your surface footage in specific materials. A high-speed steel end mill is going to have a lot less surface footage. Amount of material can be removed. It's volume of material than a solid carbide tool. Different coatings, different manufacturers can make a difference in surface footage. The other determining factor is the material that we use. So if you're cutting aluminum, you'll have a lot higher surface footage. Or if you're cutting an Inconel, a Hospitoid, high carbon alloy of some sort, like a 4140, 4340, those are going to have a lower surface footage. Now, there are some charts out there, some charts that I even hand out in class. They'll give you a rough idea of where to start with this. Really, you need to look at the tooling manufacturer at their specific tool and ask them, cutting this type of material, what's the recommended range of surface footage? We use aluminum at about 700 surface foot. Some of the harder materials like 4140 may be as low as 175 surface footage. So we're going to use a number for that. And then divided by the diameter. The diameter is the diameter of your cutting tool. Okay? So we could do one of these real fast. So let's use 500 surface footage. So 3.82 times 500. That's surface footage, surface feet per minute, divided by a 1/2 inch diameter tool. Okay? 3.82 times 500 should equal 1910 divided by a 1/2 inch, or 0.5, should equal 3820 RPMs. So that's going to tell us how fast we turn our end mill in this application. So 3820 RPM. We're going to leave that number up there and talk about our second formula really fast. So that's for our speeds. Our second formula is going to give us our feed rate. I'm just going to leave that number right there so we remember it. So feed rate is going to be your RPM times what we call chip load. We'll talk about that in a second. Times the number of flutes. By flutes, we mean the cutting edges of your end mill. And as you guys know, those come in 2, 3, 4, even 6 flute end mills. So let's talk about these numbers. Our RPM, obviously we had to calculate our speed first, so we have our RPM is 3,820 times our chip load. So chip load is really the measurement of how thick your chip is. The larger that number is, the thicker the chip becomes, okay? So we have some standards for that we use, and again, this can depend a lot on the type of tool you're using, the manufacturer. I like to just use a nice round figure of 5 thousandths. So anywhere really between 5 and 8 thousandths, 4 and 8 thousandths is a pretty safe number. So just to start out for this example, we use a 5 thousandths chip load, and then multiplied by the number of flutes. So do we have a 2 flute cutter, 3, 4 flute cutter? You put those number of flutes in here, okay? Let's say we're going to use a 4 flute end mill. That equals our feed rate, okay? And that feed rate will be in inches per minute. So if we do the math on this, pull out a calculator to do this, I believe we have a 76.4 inch per minute. Inch per minute feed rate. So it's 76.4 inches per minute, so that's going to go on a G1 line. So when we do our program, you'll have a G1 to an X or a Y location with a feed rate of 76.4 inches per minute. So those are our 2 formulas. These are really important formulas you guys want to learn, memorize, our speed and our feed formulas. Okay? Write those down, keep them on your fingertips. It'll help you a lot when you're programming. Or you're on the machine and you have a feed or a speed issue, you'll know how to recalculate those and check to make sure those numbers are right. You do want to check that every time you write a program. Use these formulas, calculate your speeds and feeds correctly each time. Thank you, keep making chips.